good morning or good afternoon to everybody. Thank you to the organizers for giving us the opportunity to present this study on anticipated maturity on yellow fleshed kiwi fruit. And in Italy, since some years ago, we experienced this anticipated maturity and into pre-harvest physiological fruit drop, which reached about 25–30% in some orchards. And here I'm reviewing some symptoms on stalk. You can see that the dry tissue appear on the basal part of the stalk or at the distal part of the stalk. We have also intermediate conditions here, as you can see. Another symptoms is on the berry. You can see that for the stalk, we have no apparent symptoms, but the fruit, the berry is shriveling. Fruit drop is quite common in other crops, such as apple, and also it can reach up to 30% percentage, and in some cultivars. And the factors involved in range from microclimate variables, water stress, plant mineral nutrition, and berry sugars import, and also root system dysfunction. And particularly on grapevines, we know this physiological disease, the bunch stem necrosis, which is very similar to the symptoms we observed on kiwi fruit. You can see the shriveling berry here and the dry rachis or not dry rachis. So reviewing the possible causes of bunch stem necrosis on grapevines, you can find common issues such as the magnesium, calcium, or nitrogen imbalance in the soil, and the high potassium, magnesium, or potassium and calcium ratios, the absence of pathogens involved in the bunch stem necrosis, and also magnesium deficiency, and also that if you spray magnesium, the necrosis could be reduced by 40%. As you can see, there are very frequent similar messages about mineral nutrition. So if we improve calcium and magnesium nutrition, fruit drop might be reduced. Also, fruit drop is a part of a natural process in the ripening of fruit. And ripening is, of course, triggered by the senescence. So slowing senescence might reduce fruit drop. How to do this? And we know that low levels of nitrogen might accelerate senescence. So increasing nitrogen supply might be in favor of fruit drop reduction. And also ripening process are, of course, related to ethylene hormone. And so using in apple, the two compounds, such as the 1-MCP and the synthetic oxide NAA are used to reduce fruit drop because they interfere with ethylene. So let's say inhibiting ethylene would reduce pre-harvest fruit drop. So based on this background, we test the effect on fruit drop of improved magnesium and calcium nutrition, increased nitrogen supply, and the spray of these two compounds, the 1-MCP and the NAA. Here are the experimental sites in the south of Italy, and some information about orchards. And soil was not tilled, basically, and soil moisture was kept at about 70–80% of field capacity. So the treatments we applied on about 10–15 vines each treatment. In order to increase the foliar sprays, we have the control treatment with the 3 sprays, and we integrated this control treatment with 8 sprays, and the last one was in June. Then we increased, the other treatment was the increasing of total nitrogen supply. So we reached these 2 levels, 135 and 160 kilogram nitrogen. And also the timing was adjusted compared to the control. Also, we spray in a single application, the 1 MCP in midsummer, and also the application of the synthetic oxide was extended from late June compared to the control to late August, and we add 3 more sprays. About the results, you can see that the first year, this is the fruit drop dynamic in the control plot, and it reached in about 20 days, it reached about 20%, while in integrated plots, the fruit drop was reduced, significantly reduced, and particularly at the site 2. Just to have some statistics on the results, you can see the benefits of the integrated mineral nutrition compared to the control. And the second year of the experiment, we get a similar trend in fruit drop dynamics in both sides. And what's up about the nitrogen application? As you can see, moving from 95 up to about 160 kilogram nitrogen per year, you can see that the fruit drop tend to significantly reduce. And remaining within this block here, which is the minimum level of nitrogen at 95, you can see that when we add the synthetic oxide or the 1 MCP, you can reduce the fruit drop incidence from about 8% to down to about 4%. And when the nitrogen is increased up to 135, you can see this column here reducing it down to about 2% within the same sites. At the site 2, we did not get so much differences because levels were, fruit drop was low in all treatments. Some information about fruit quality and about the bricks level, you can see that substantially there was no differences among treatments, excepting for these 2 treatments in site 2, which were less mature compared to all these others. About the pressure, you can see that firmness tend to be higher in those blocks where we add more nitrogen or the oxide, the synthetic oxide. And also the dry matter concentration was more or less similar, ranging within a few points around 20%. And it tend to be a little bit higher in these treatments here, receiving more nitrogen compared to the last one. We look also the root systems to check the mycorrhization in presence in roots. And we noted that with the high incidence of the mycorrhization index, for example, this column, the first, reaching about 40 value of the index, the fruit drop in the brackets tend to be lower compared to the other types of roots. However, the significance of the results was not in favor of the benefits of the mycorrhization. However, this could be explained considering that the index has been calculated on root segments, and of course, we have much more good health segments in this kind of roots. This may be taken into account in next activity. We did a lot of mineral nutrition analysis on different organs, on stalks, for example, on berry, and on leaves. And basically, we did not identify any clear pattern among the treatments. There was no significant differences among treatments. And we learned that, of course, the three organs grouped differently compared to the mineral nutrition. And particularly looking at the stalk, the blue one here, you can see that the stalk dots spray much more along the component 2 of the principal component. And this is because, and less along the dimension 1 here. And the dimension 2 is mainly driven by potassium and magnesium ratio, phosphorus, and so on. So look at this ratio now. We can see effectively that a fruit drop is roughly linearly correlated with the potassium and magnesium ratio, excluding this dot here in the fitting procedure. And also similarly for potassium and calcium ratio, and also using this other way for ratio. This is a very good, quite good correlation. Of course, we have no references data to judge the level of potassium or calcium, but what we can see is that in the stalk, for example, we have a roughly stable value of calcium concentration across all treatments, and also for the magnesium. While potassium here, you can see it change across the various treatments, and also it correlate, the potassium correlate with the fruit drop incidence. So it seems that potassium nutrition of the stalk would be a key point to understand fruit drop. So also we noted that fruit drop developed within 20 days, but we asked if there was a possibility for an early detection of fruit drop. So we make some measurements with the fruit detachment force, and of course late in the season, fruit detachment force is clearly associated with the symptoms. So this stalk here is very dry with very minimum fruit detachment force compared to the other one, which is very high and in good health. But early in the season, you can have no symptoms at all in July, for example, while the fruit detachment force is different. Starting from 5.1 down to 2.3 kilogram. And effectively, when you monitor the fruit detachment force along the season, you can see that the group differentiated at the end of, close to the end of season, are already separated at the beginning in July. And of course, you can see that fruit detachment force could be correlated in some way with the incidence of fruit drop 6 weeks before harvest and also 4 weeks before harvest. So this could be an interesting point to go deep in this point. So now I'm going to conclude. We have learned that increasing nitrogen supply could reduce fruit drop incidence by 75%, and that spray more calcium and magnesium could be in favor of the reduction of fruit drop as well. And also that high potassium, calcium, or potassium magnesium ratio were associated to high fruit drop. Also, importantly, we noted that one that 1 MCP and NEA reduced free drop by approximately 50%. And for the future, it would be interesting to test more than a single application of the 1 MCP, and also to study better the root turnover and some root-to-shoot senescence signal triggered by poor soil aeration. Thank you very much.